All right, we have to do the puppy problem. So here is the paragraph. So I'm going to go ahead and grab that and copy that and open up Notepad++ and paste it in. All right, so this is what we're going to be doing. We have assumptions. Should have done this earlier. Scope, constants, input, calculations slash logic, oops, and output. I'll make a bunch of extra spaces so we can move around. All right, so remember scope and constants are part of assumptions. So what's the first thing we do? First thing we figure out what it is we want out. And it says provide a receipt that shows. And here we go. So this is what they want out. So I'm just going to copy that, paste that into my output. And I'll start cameling it down. So they want to know the number of puppies. So we'll do that. And then the price per puppy. So price per puppy. Good. And then the processing fee. That's a little bit wordy, but we'll do it anyway. Processing fee per puppy. I said that might not fit in the block in Visual Logic. Okay, and then we want the total charge per puppy. Whoops, not that. And then the total charge. Okay, so when we take a look at these, we can see that we have number of puppies, price per puppy. So price per puppy is going to be logic, processing fee is going to be logic, and these two are going to be math. So these four have to go into the calculations. Control C, Control V. And number of puppies, though, someone has to tell us that. So we'll do Control C and Control V. Next thing is our scope, and we'll take a look at that. We can see we have a 300, 500, a 10, and a 150. So those are all our constants. So we'll say you can see that we have a teacup puppy. So let's do the teacup rate, and that's going to be equal to 300. Whoops. And then we also have a Great Dane rate. So Great Danes are 500. There you go. So we'll have a Great Dane rate, and that's equal to 500. And the next thing after that is we have a $10 processing fee for not AKC, and then one for AKC. So let's do AKC processing, and that's going to be equal to 150. And then what do we call this other one? No AKC processing, and that's going to be equal to 10. Great. All right, so that's you should be able to do that as fast as you can. You can see that we've already got a big chunk of this done. So next thing I'm going to do is Control C for space equals space and put it next to each one of these calculations. Start with the bottom. All right, so if I know how much to charge for each puppy, and I know how many puppies they have, I just have to multiply them together. So this is going to be the price per puppy. No, that's not right. Yes. No, the total charge is going to be the total charge whoops, no, let's try this again, is going to be the total charge per puppy times the number of puppies. There we go. And then the total charge per puppy is going to be the price per puppy plus the processing fee per puppy. That's a long word. I don't like that, but we'll keep on doing it that way anyway. All right, and then the processing fee per puppy and the price per puppy, it all depends on logic. So we're going to have to make a decision. So the first one we'll say is if the puppy type equals teacup, then the price per puppy is going to be the teacup rate. Else, meaning that it's not a teacup, meaning Great Dane, then the price per puppy is going to be equal to the Great Dane rate. Now, notice on here, instead of doing teacup equals yes, which I've done in the other problems, this one I'm going to do puppy type equals, so just so you can see the different way. Both ways are correct. And again, that's why I say that each student will have a completely different problem statement, because what you name it is really up to you. Now, next we're going to have to do is the processing fee. So we'll say that if the processing type equals AKC, then the processing fee per puppy is going to be the, what do I call that? I call AKC, processing. Oh no, I didn't do rate on that one. I should do rate. Makes it too wordy, but I like putting rates on rates, so that makes sense. AKC processing rate. And what happens if it's not AKC? Then it's else. And then the processing fee per puppy is going to be equal to the no AKC processing rate. If we didn't put rate at the back of these, it wouldn't be wrong, but you want people to take a look at your code and go, what are they doing here? Well, if it's AKC, then we're putting a rate into that. So that works out better. All right, so that is everything except for our scope. Okay, and let's see what scope. Only one customer. Only two types of puppies. And only two types of transaction fee. So they said this in the paragraph, but again, when they put it in the paragraph, I'm making assumptions that all this is exactly the way they want it, and then I'll come back and I'll talk to the user and I'll go over the scope with them and say, only one customer at a time? And they go, yes, well, one customer, but we also want the total for the day. And it's like, wait a minute. Well, my code will not do it. As we move down, we're missing some input. So we have a puppy type that has to be input. So we'll do puppy type. And then I'll put on the parentheses what I'm expecting them to type in. So it'll be teacup with a space, or Great Dane. So they're going to be typing one of those two things. And then the other one is going to be the transaction type or processing type. And again, that also is going to have either AKC. So I have to match or not AKC. So if they type in not AKC, that's not the same thing. It won't match AKC down here, and it'll do the false. I still like doing yes or no. It makes things a lot easier. So if this was, instead of puppy type equals teacup, if it said teacup equals yes, it's less typing and it makes a little more sense when you take a look at your code than it does here. But like I said, both are correct, and you'll find that when developers get together and people show their solutions, there are great arguments in the room on, wait a minute, why did you name it that, and why are you doing it this way? Because there's many ways. What I always say in the classroom is that there are probably, depending on how complicated a problem is, the more complicated, the more correct solutions. So there may be dozens of correct solutions. Of course, there's an infinite number of non-correct solutions. So you have to be careful. As long as you're following my rules for doing the problem statement, you'll never have a problem. So if we had this math down here, total charge, and it was price per puppy times the rate plus number of puppies plus. So if I'm doing all sorts of complex math down here, that's not right. So that's why we do the bottom up methodology, to make sure that we're going to have the most simple problems. If you're doing math inside your decision, that would not be correct here, because we only need to do math once outside rather than twice inside. So again, these rules will make it so that you are a better programmer and come out with more efficient code. All right, on to flowchart.